We can describe impulse by using a force versus time graph. A force time graph will always have force on the y-axis, and it will always have time on the x-axis. You will, on your unit test, I promise you, get a force versus time graph. You will most likely, on your diploma exam, also get a force versus time graph. When you see that graph, before you even read the question, I want you to think 3 words. I'm going to ask you on Monday, hey, what are the 3 words you think of when you see a force versus time graph? The answer is area equals impulse. Every single time, I want you to think of those 3 words, area equals impulse. So much so that, in fact, I've already written it down on our little always board at the back here. Okay, force versus time graph, think area equals impulse. Every single time. Now, you got to watch out for a few things, right? Okay, watch out for the axes. We're always going to have force on the y-axis, time on the x-axis. But what about the units? Maybe force is in kilonewtons, and maybe time is in milliseconds. Watch out for those, right? But the bottom line is, like, the crux of this is always going to be 3 words. Area equals impulse. What do I mean by that? Well, I mean that the area between the line, that little red line that you see in this graph, and the x-axis is going to be the impulse. It's going to be delta P. Now, you see some of it, you really see 3 shapes here. You see a triangle right here. We'll call this A1. Well, then there's another triangle right here that we'll call A2, and there's another one right here that we'll call A3, a rectangle here that we'll call A3. You want to find the area between the line and the x-axis? Calculate the area of all 3 of those. Set A1 to be positive because it's above the x-axis. Set A2 and A3 to be negative because they're below the x-axis. So the basic thing you got to remember is area equals impulse. Then you got to watch out for units. You got to also watch out for the area above the x-axis to be positive and the area below the x-axis to be negative. A lot of times, probably most times, that's it. Get the area. Watch out for the units. Make sure you account for positive and negative. That's it. But there are times, maybe I'm going to say 20% of the time maybe, when you're asked to go a little bit further. Even when you are asked to go a little bit further, I want you to still go through what we just did. Area equals impulse, watch the units above and below the x-axis. Do that first. But if you're asked to go a little bit further, like for instance, if you're asked to solve for the change in velocity or the final velocity or the mass of the object, then you're going to do what you just did, and then you're going to use this equation. Delta P is equal to m times delta V to solve for mass or delta V. Look, you've already got delta P. It's the area. It's the impulse. It's the area. We know that area equals impulse already. We've dealt with that. Set that equal to m times delta V to solve for one of the other variables. Be careful. Do not ever use this equation in the context of a force versus time graph. Why not? Like, it should be valid, right? Impulse or area is equal to F times T. We know the impulse. It's the area. The time is easy. It's just from start to finish in the graph here. The problem is with the force. What's the problem with the force? Like, why do I not want to deal with the force here in this equation? Yeah? Yeah, it's changing, right? Technically, it's valid to do this, but F in this case would stand for the average force. Tell me what the average force is in that graph. Like, I don't know. I don't know what it is. Like, don't even go there. Don't even try using that. These questions are always solvable by either area equals impulse or area equals impulse and delta P is equal to m times delta V. Don't ever try to use F times delta T. 9 times out of 10, it will lead you astray. Let's do example number 1. It says a 4,500. Oh, you know what? Before we read this question, what do you notice? What jumps out at you? There's a graph. Like, you can't possibly not see a graph there. That graph is force versus time. And as soon as we see a force versus time graph, even before we read the question, we're able to identify basically what we're going to do. What 3 words come to mind when you see this graph, even before you read the question? What is it? Got it written down on the back here in green. Force versus time graph, 3 words. Area equals impulse. Good. I'm going to write that down. Area equals impulse. All right? Watch out for units. Remember I said watch out for units here? This is force times 1,000 units, so it's not 0, 10, 20. It's 0, 10,000, 20,000. You got to watch that or you're going to be off by a factor of 1,000. X-axis units are good. 4,500 kilogram truck begins at rest and accelerates over time, is illustrated by the graph. What's the impulse experienced by the truck? And what's the final speed of the truck? Tell you what, let's worry about the impulse first, because that's our easiest part. Area equals impulse. There's 4 sections in this graph here. 4 different shapes here. 1, 2, 3, 4. I'm going to say A1, area 1, 1/2 base times height. Because it's a triangle, right? 1/2, the base is 5. And the height is what? Looks like it goes to about 15. Is that right? Yeah? No? 15,000. Right? Watch that unit. 15,000. That gives me a number here of 37,500. And the units would be Newton seconds there. Area 2 is a rectangle, so we use base times height to find that one. The base goes from 5 to 15, so it's 10 seconds. The height is 15,000. So that's going to give me 150,000 Newton seconds. Area 3. That's a triangle again. 15 to 20. The base is 5. And the height is, once again, 15,000. 37,500 Newton seconds. And finally, area 4, also a triangle. Also 1/2 base times height. Base is, well, it goes from 20 to 25.
Good afternoon, everybody. It is almost time for our closing lesson.
The height of this is also 15,000. We go from 0 to 15,000 down below the x-axis. But we're going to make sure we make this one a negative value because it's below the x-axis. Don't forget that. That gives us negative 37,500 Newton seconds. We add all these up. The total impulse ends up being equal to the total area, which is positive 187,500. We're going to round that to 2 digits. And we end up getting positive 1.9 times 10 to the 5 Newton seconds. There's the impulse. Now we've got to find the final speed of the truck. There's only one other thing that we can do, one other option, and that's to set the impulse we just found equal to m times delta v. So rearrange this. Delta v is equal to delta p over m. Delta p is, use the unrounded number here, 187,500, divided by 4,500. Gives me a change in velocity of 42 meters per second. Now really we're looking for the final velocity, final speed, but in the end if the initial is 0, then the final is the change in velocity. Great. Homework over the weekend is to finish up worksheet number 8. It's question number 8 on worksheet number 8. You've already done the rest of it. In addition to that, I'd like you to take a look at practice question set number 3. And of course, we also have quiz number 2 on Monday as well.